If I have t equals time, I could have p of t equals position as a function of time. And we've discussed the fact that if my function is giving me position, its derivative has a particular meaning. We would call it p prime of t. I could also, if I wanted to, call it v of t because it's the velocity. Okay. The derivative of position is the velocity, and that would be the instantaneous velocity as a function of time. Okay. Now, that's just saying that's the rate of change of my position. But velocity can also change. So I could measure the rate of change in my velocity. I'd be taking the derivative of the derivative, which we call the second derivative, because we're very creative in our naming. I can denote that as p double prime of t. That's the second derivative of position with a function of time. That would be the first derivative of velocity as a function of time. And if we think about what do we call it when we're measuring the rate of change in the velocity, I'm just going to call that a of t for the acceleration. So this is a rate of change of a rate of change. Now I can talk about how quickly does the acceleration change. That would be the derivative of the acceleration, which would be the derivative of the derivative of velocity, which would be the derivative of the derivative of the derivative of position. That would be the third derivative of position, would be the second derivative of velocity, would be the first derivative of acceleration, and it's something that's called the jerk. Okay? And it's actually rather important. There was a time when scientists were shooting some rockets up into space and they kept blowing up. And they said, oh dear, we don't like this. We're spending lots and lots of money and just blowing things up. And while that's great fun, they're going to take our money away if we keep blowing things up. What they figured out is they were solving all sorts of equations to control the position, the velocity, and the acceleration of things. But the acceleration was changing so fast that there was this jerk, and it was causing rockets to explode. Okay. So third derivatives can actually be important as well. So higher order derivatives are just derivatives of derivatives, or rates of change of rates of change. In the example of position, velocity, and acceleration, we've got familiar names for these things. I do want to just point out, though, how higher order derivatives, in this case second derivatives, can actually be very misleading. Politicians love second derivatives. Here is my example. Okay. I'm going to list the year and the number of violent crimes that occur in a town. So we're going to suppose, and you really have to suspend your disbelief here, okay? We're going to suppose that we live in a town that has a pretty constant population. So that if there's a change in violent crimes, if the crimes go up, it's not because the population went up. And if the violent crimes decrease, it's not because there are just fewer people there to commit them. The population is staying relatively constant. Okay, that's not too unbelievable. What's unbelievable is that I am the mayor of the town. Okay, so I've been the mayor of the town since the year 2000. Oh, we'll say 2010. Okay, and in the year 2010, the number of violent crimes that we had was 300. Okay. And then in 2015, the number of violent crimes that we had was 600. So violent crimes doubled. And again, the population was staying relatively constant. So it's not that suddenly we just had more people, so therefore we had more crime. I probably wasn't doing a good job as mayor of controlling the violent crime. Okay. In 2020, we had 750 violent crimes. So now I'm up for re-election, and I've always been running on this bill of I can control violent crime. I will keep violent crime down. Not doing such a good job. If I look, violent crime has been increasing since I have been in office. So the rate of change in violent crime is positive, and this is a very negative thing. It should not be positive. We don't like violent crime. So I look here, and I say over my first 5 years in office, violent crime went up by 300 violent crimes in 5 years. And by next 5 years, violent crimes still went up, but they only went up by 150. So the rate of increase in violent crime is down, and you should vote for me. In other words, things are still getting worse, but they're getting worse more slowly. That's what that second derivative is telling us. Okay, so second derivatives are rates of change of rates of change. That means acceleration if we're talking position. It can be kind of deceptive if you're talking about whether things are getting better or getting worse, as we were in this particular case.